for sticking with it. All right, find V naught of t using Laplace transforms. Now we have to use Laplace transforms here. We don't have to. It becomes a lot harder if we don't. We can't use the formulas because our voltage source is not DC. So you could solve it straight up with differential equations. That's what Laplace transforms are. It's solving it using differential equations because the Laplace transforms help you solve differential equations. You just shortcut that part.
So our voltage source isn't DC?
It's not. It's e to the minus t.
Oh, I see.
Yeah. It's not a constant source. Yeah.
It's icky.
Yeah. It's not AC either.
Yeah, that's what I was.
Yeah. It's just, but it's not 6. Yeah.
Constant.
Right. So what we have to do is we take the Laplace transform of all of our components and we transform it into the S domain. And the reason we want to do that is because in the S domain, everything adds like a resistor. So in the time domain where we've been working up until now, capacitors have a voltage, well, the current across a capacitor is C dV dt, and the voltage across an inductor is L di dt, which is not at all like resistances that just kind of add together. So we want to put this into the S domain where everything adds like a resistor. So we take the Laplace transform of e to the minus t. Can anybody tell me what the Laplace transform of e to the minus t is?
1 over s plus 1.
1 over s plus 1. So that'll be our voltage source. What's the Laplace transform of a resistor?
Nothing.
It's just 7.
Same resistance.
Same resistance. Now the Laplace transform of an inductor, so we're going to have an inductor plus we would have a little voltage source if there was any current through that inductor at 0 minus. Is there any current through this inductor at 0 minus?
No, because of the step function.
No, because it's got a unit step function on the e minus t. So the u of t means that the u of t is 0 before 0 and 1 after 0. So that means before 0, this is 0.
Yeah.
So that means there is no current before. Okay. So we can then transform our inductor. How do you what's the transformation of an inductor?
S times L.
Yep. So this will be just 1s.
And then you add a voltage source.
We add a voltage source, but what would our voltage source, what would the value of our voltage source be? 0.
That's what you just said.
0.
That is what I just said. That's okay, I'm used to that. That's what my SI sessions always are. If nobody asks, I just say it twice anyway. And then wait for someone to ask so I can say it a third time. Okay, now we're going to transform the capacitor. So what is the transformation of a capacitor?
1 over s times c.
1 over s times c. So 1 over s times 1/10. 1 over 1/10 is 10, so this is the same as 10 over s. Plus, we would have a voltage source if there was any voltage across the capacitor at 0 minus. Is there any voltage across the capacitor at 0 minus?
No.
No. So we're lucky with that. All right. Now we're trying eventually to find the voltage across the capacitor. So we could do that by doing a voltage division, because this is, once we have it in the S domain, everything we know from chapters 2 and 3 all apply. So voltage division tells me my voltage across my capacitor equals my total voltage, which is 1 over s plus 1, times the impedance, that's our fancy name for resistance when we're not in the time domain, across the capacitor, which is 10 over S, over our total impedance, so we add it all up, 10 over S plus S plus 7. Now I want to get this into a nicer looking form. So I'm going to bring this S that's in the numerator up here down to the denominator. And then I'll multiply that through. And then that's not in the form that I like to factor. I like having my S squared in front, so S squared plus 7S plus 10. If that S squared had a coefficient, you would need to factor it out. You want your factors to all be starting with S. So then I get, when I factor this, I get 10 over S plus 1 times S plus 5 times S plus 2. So that's V naught of S. So that's my voltage in the S domain. But I need my voltage in the time domain, so I have to take the inverse Laplace transform. I can't take the inverse Laplace transform of it the way it is because I don't have anything like that in my tables. So I know that V naught of t will equal the inverse Laplace transform of 10 over S plus 1 times S plus 5 times S plus 2. But to find that inverse Laplace transform, I'm going to have to do partial fractions. So this equals, so I'm going to write 10. Do y'all want me to do 10 or 1 and multiply it by 10 later? 10 is fine. Okay. 10 over S plus 1 times S plus 5 times S plus 2 equals A over S plus 1 plus B over S plus 5 plus C over S plus 2. Now I have a real quick way of doing this when they're all linear. But I'm not going to do that because then they'd have too many questions. All right, so 10 over S plus 1 times S plus 5 times S plus 2. But I can do it in my head. Just letting y'all know. Okay, so
Well, what about the questions we'll have?
Yeah, no, I'm not gonna do it. I'm just.
No, she needs to study too.
Yeah.
I'm kidding. Yeah.
Okay, so no, I'm doing it. I'm doing it the long way. Okay, so I get a common denominator. So this is A times S plus 5 times S plus 2 over S plus 1, S plus 5, S plus 2 plus B times S plus 1 times S plus 2 over my common denominator plus C times S plus 1 times S plus 5 over my common denominator. So now that I have a common denominator, I can multiply through by the common denominator and it goes away. So then I have 10 equals A times S squared plus 7S plus 10 plus B times S squared plus 3S plus 2 plus C times S squared plus 6S plus 5, or 10 equals, I'm going to get all of my s squareds together. So I have as squared plus bs squared plus cs squared. So it's s squared times a plus b plus c plus, now I'll get all my s terms together. So I have s times 7a plus 3b plus 6c. And then I get all my constant terms together. So I have 10a plus 2b plus 5c. So I know that what's on the left-hand side has to equal what's on the right-hand side. The left-hand side doesn't have any s squareds at all. So a plus b plus c has to equal 0. The left-hand side also doesn't have any s terms at all. So 7a plus 3b plus 6c has to equal 0. And then the constant term has to equal 10. So 10a plus 2b plus 5c has to equal 10. And then you have 3 equations and 3 unknowns, which you can solve in different kinds of ways. You wouldn't have that, I don't think that wouldn't show up on an exam, but I'm just going to do it here real quick. Somebody call out the coefficients to me, please.
7A.
No, the first one's just a plus b plus c, right? So 1, 1, 1, 0, and the second one was
7, 3, and 6.
oops. Seven,
3,
3, 6, and 0. And the last one was
10,
10,
2,
2,
5.
5, and 10.
Yep.
So A is 5 halves, B is 5 sixths, and C is negative 10 thirds.
That is really handy.
Also, I can tell you, if I were to do this, so negative 1, it's 4 and 1, 10 over 4. 5 halves, A is 5 halves.
Yes.
Negative 5, that's negative 4, negative 2, negative 6. Negative 5 6, B. What was B? Positive 5 6. And C, negative 2 is negative 1, that's 3. 10 thirds? What was C?
Negative 10 thirds.
Negative 10
Negative
thirds.
10 thirds.
Negative 10 thirds. Okay, so then once you have that, then you can take the inverse Laplace transform, because you have, this is 5 halves, this is 5 sixths, and this is negative 10 thirds, and that just becomes 5 halves e to the negative 1t, 5 sixths e to the negative 5t, and negative 10 thirds e to the negative 2t. Everybody here seems to be packing up and wanting to go away. So I'm not going to. Everybody know, y'all know how to do that?
I got that answer.
Okay.
I was able to get it also.
Yeah, 5
Okay.
over 6
Yay.
e to the negative 5t minus 10 over 3 e to the negative 2t plus 5 over 2 e to the negative t ut.
Yep.
I figure, in a roundabout way, even if we didn't put the same values for the denominator of a, b, and c, it still works out the same.
You do
I
get
got
the same
negative
answer.
10 thirds e to the negative 2t as the last one.
Yeah.
And it looks like I probably did the same thing last semester, because I don't have the final answer written down here either. I just have inverse Laplace transform. It looks like I did the same thing. I got to the end and said we quit. All right. So thank y'all very much for coming. I will be sending out a survey, a review for y'all to review SI for this class. It's not the same as the evaluation for the course. Please do it. I always beg people to do it. Please do it. It really makes a difference. Thank you.
Just send a reminder when you do it.
Okay.